Hello engineers, another sample problem for mechanics of deformable bodies, module 2, under strain. The problem states, the block is deformed into the position shown by the dashed lines. Determine the average normal strain along line AB. So first, recall natin yung normal strain. Designated by the notation epsilon. That's also equal to the change in length divided by the original length. First step natin is to determine the original length of line AB. So referring at the figure, create lang tayo ng projection here, and this is 30 millimeters. So yung total is 70. So yung remaining here is 40 millimeters. And then we have the height na 100 millimeters. So therefore, considering the triangle form, we have the length AB that's equal to the square root of 40 millimeters squared plus 100 millimeters squared. Therefore, ang length ng ating AB is 107.703 millimeters. And this is our L sub O, or the initial length. For us to determine the delta, the change, we need to determine the final length and then subtract it by the initial length. So going back sa figure, we have the AB prime as the final length of line AB. And as shown, B prime has moved, and yung movement na yun should be measured. So let's see. Ang total nito is 100 millimeters. And from the top, we have here 55, and then 30, and then we have this remaining, that is 100 minus 55 minus 30, and that's 15. So this one here is 15 millimeters. So kung ito 15, and then we have 30 here, therefore this portion is 30 minus 15, so that's 15 millimeters also. If this is 15, from this point to this point, therefore this one is 30 minus 15, that's 15 millimeters also. So sulat lang natin, we have B moves 15 millimeters to the left. And then we also have to measure the movement of point B upward. So next, let's focus on this triangle we have here. Itong triangle na to. By Pythagorean theorem, we can measure the height of this triangle. So pangalanan na lang natin as y, yung height. And then we have formed this triangle. So this is 110 millimeters, and then this is 15 millimeters. So y here becomes equal to the difference of the squares, no? So 110 millimeters squared minus 15 millimeters squared. So y becomes 108.972 millimeters. So bakit natin kinuha yung triangle na yon? Because this portion can be projected papunta doon sa final location ng B, which is B prime. So if y is 108.972, this means that from this point to this point is also 108.972. And that means that B moves by the difference of 108.972 and 100. So B moves 8.972 millimeters upward. Sulat natin here. B moves 8.972 millimeters up. So now let's focus on getting the length AB prime. So we have this triangle that can be formed. So let's use a more contrasting color here. Ito yung new triangle that can be formed. So we know that B moves 15 mm to the left. Initially, meron tayong 40 millimeters and then it moves to the left by 15 mm. So the remaining will be 25 millimeters. And then it moves upward by 8.972. So yung height niya becomes 108.972 millimeters. Extracting yung formed triangle, we have here the height, the base, and the hypotenuse. Here, we have 108.972 millimeters, and this one is 25 millimeters. This is point A, and this is the final location of point B, that's B prime. To determine the length AB prime, we have the sum of the squares. That's 108.972 millimeters squared plus 25 millimeters squared. And then we'll have AB prime equal to 111.803 millimeters. And this becomes the final length of line AB. So going back sa formula, we have the change, which is equal to the final length, that is 111.803 millimeters. And we have the initial length, that's 107.703 millimeters. Therefore, ang ating change is 4.1 millimeters. And then we have the value of strain, that is the change divided by the initial length. We have 4.1 millimeters divided by 107.703 millimeters. Strain now becomes 0.038 millimeters per millimeters. That's it. I hope you learned something. This is Engineer Lance. Thank you for watching.